But we have the bonus round. First thing we have to do is to create another function. We can duplicate this one and call it smooth transition, smooth toggle actually. I just want to keep the naming convention on the model in order to find myself, don't lose myself too easily. We won't need all these things. We are going to make them in another place. This one too. This first person view, yes, we need that. We need another Boolean variable is camera in transition. Alright. This one should be false by default. It's false, it's fine. We will use it later, but let's put it in the function just to remember. And here we don't want to call this function anymore. We want to call the smooth transition, smooth toggle. It's all we have to do in the player controller. We can go back in the character. And from here, we will need first some... we will use a timeline in order to switch the position of the camera. That means we will using a new camera component, and the timeline I will explain just after. I'm just mismatching orders in my plan. I have a plan, but I'm not following it. So we can take the first person view camera and we will duplicate it. And we will call it switchable. Switch. The setting will be the same. It will be active. Okay, the first person camera will be deactivated because we won't use any of this camera anymore. And we will make we will create also a duplicate of the arm. And like the first person view arm, it will be attached to the mesh, to the character skeletal mesh. And the camera switchable will be attached to the arm. And if you remember the previous video, the spring arm we were using for the first person view is actually attached to the head. So let's go here and do the same to the head bone. Alright. So, why is our camera at the bad place? Okay, it's because the location and rotation value were not set to default anymore. And except from this, I think we are good. Switch. Here we have the same lag. Yeah. And the same target arm length and the same position and rotation. Let's just test to see if we are in the correct first person view, and if it's all working. It's all working. Okay, now the timeline. So we will create a timeline. Timeline is essentially an useful tool in Blueprint, and I called it yeah, camera transition. Sorry, I've wrote that and I explain you. At least if you are a beginner, you will be interesting to know. So it's a player, and what he played a curve. If we open the timeline, we have possibility to have tracks, and we will have one tracks of float kind. You can have several kind of tracks. Here we just want a float one, and we call it alpha because it will be used to change the alpha inside the interpolate node. Interpolate is something to switch from one value to another in a smooth way using an alpha value from 0 to 1. At 0 you have the value A, at 1 you have the value B. And as the timeline is just a way to play backward and forward along a time spline, having different values depending on the time. Yeah, when we will play the timeline, we will send the alpha to the lerping system, and we will change the different values for the camera and for the arm. So time on this axis and value on the vertical axis, we can create a point on the time by shift clicking on the view, and you'll see we have a curve. Let's set this to 1 at time 1, so at 1 second the value will be 1, and it will start at 0, 0. So it's just a linear transition when we are going to play this timeline. Alright, let's go back in the event graph, and we are in the event graph and not inside the function, because timeline can be created only in events graph. It's a limitation of this tool. And now you can see we have the alpha value that is outputted by the timeline. So in order to control this timeline, in order to say yes, play or reverse, we are going to create custom event. And mismatches my, I don't know, TIL is better for timeline and CE is better for custom event. So custom event transition to first person view, and we can create another one or copy this one, but the name is not copied anyway. And we can call this one transition to third person view. And we can compile to remove this warning. So what are we going to do when we call this? We are going to play from start when we want to go to the third person view, because the default view is the first person view. And we're gonna to reverse from the end, so to go from 1, 1 to 0, 0 when we want to reverse to the first person view. And we will also Now let's make it working just a bit, and then we will make what I was thinking about. So where are we going to change, what value are we going to change to get the third person view? Well, if we go in the viewport and we select the camera spring arm, we can see here the spring arm length is the actual difference between this view and this view. If we set this to 300, you can see we are in third person view basically only, but for now it will be enough. So we want to modify this target arm length. And if we go back here, we can select our spring arm, we can set arm length, and here we have the access to the value. So when we are running this timeline, you have two main outputs: the finished output when the timeline is completed, and the update, which is sending which is firing every update, meaning every frame, I guess, in this case. So we will use this to change the arm length value, and we will make a linear interpolation between two values depending on the alpha. 0 will be this value, the first person view value, it was -9 if you remember well, and 300 for the third person view. We can test and see if it's working. It's not working because we are not calling these events. Custom events, what are they? It's just events that you can call like function from anywhere you want, like function, but they are belonging inside the event graph, in the main graph in your blueprint. So if we go here, I let this for later, we can call the custom event transition to first person and to third person. We have the third person, we want the first person view. So if we are in third person, we go in third person. If we are in third person, we go the opposite. But you get it. And now it should be doing something. Yeah, look, it's working. Except we are not changing this value. And so each time I press the button, I'm replaying the timeline from the beginning. And so I'm going back to the first person view for a very little moment and doing the transition to the third person view again and again. This is not what we want. You can also notice a lot of jiggering in the movement. It's because we are in opposition to the first system I show you. Here the arm is still attached to the bone, to the head bone, and so it's making a lot of movement, and even with the lag activated, it's doing it. We can reduce that by changing the lag here. Set lag, because if you remember well, by changing the lag max distance, because if you remember well, in the first person spring arm we made in the previous video, we had a very low lag in order to not have the camera going inside the head and intersecting with the mesh, clipping with the mesh. And in this one we have a larger distance, max distance lag, and we will do the same as here. So create a lerp in order to you can double click on a link to make a reroute node. In order, what I was saying, to have a larger lag only in third person, a larger max distance lag only in third person view. So it should make the thing a little better. Okay, we have a little less movement, but still it's not that great because we are still attached to the head bone, and the head bone is doing a lot of movement. And with the arm length, it's even if in first person, in first person view the movements are not super noticeable. You can see here it's quite smooth. When we are in third person view with the length of the arm, it's amplifying. It's increasing the little movement of the bone from the animation. So we will have to change this. First, we will deal with the fact that we are only playing the third-person animation. For that, we need to say that we are not in first-person view anymore when we are finished. Okay? But then we will have another problem. We won't be able to switch back to third-person view. Yeah, it's the opposite problem. Now we are calling only the reverse one. If we remember, if we are not in first-person view, we are calling the transition to first-person view, and this is playing the animation in reverse from the end. And anyway, when it's finished, it's always saying we are not in first-person view. So it's not working. We have to find a way to set this on or off depending on which direction we played the animation. We also could put it here, but I prefer to put it at the end of the transition because we are also going to change some other variable. So we have a useful thing here, it's direction. And from direction we can use a switch node, plug this finished to the switch, and when we finish, if we were going forward we will do something, and if we were going backward we will do something else. If we were going forward, it means we were transitioning to the third person view, so we are not in third person view anymore, and else we are in first person view. But we also want to change the control system, because as you can see, even in third-person view we are controlling with the FPS control system. So, same as here, we are going to change these parameters. Or we can close this one and go here, past them. So we are going forward. We don't use rotation, we use orient to movement, and we say we are not in first person view anymore. And backward, the opposite. Alright, should be working fine now. So first person control, first person view, third person view, and third person control. Something is missing, and you know what is it? It's yeah, what is it? If you remember, in first person view the camera is bind to the controller rotation, it's here, now, here, which is not the case in third-person view. So we have to change this. And also in third-person view, we are not using the controller rotation for the spring for the spring arm, or we are using it, but it's useless. It should be false, by the way. Yeah. So let's go here. It's false. Okay. But anyway, that's the reason we have this strange behavior. So we will change this. Use controller, and we will change the one from. This one is never bind. It's only the camera. I'm not sure anymore. Let me check on my. Yeah, the third-person view is using the pawn rotation. I don't know why I thought it wasn't. Control. So camera and arm, okay. Again, it was written on my notes, but I forgot. That's all right. Okay. In first-person view, we are using the control rotation for the camera, but not for the spring arm. In third-person view, yeah, we are using not for the camera, but for the controller, but for the arm, I mean. Alright, yes, better. Now the player is going in the direction you are inputting with the controller. Independently, the camera can be moved. Alright, it's working perfectly, you may say. But let's see the transition. Yeah, you can see that? This little switch, little offset at the end of the transition. And also, what is happening if I'm moving and making the switch? Yeah, the same. So we are going to fix that. And also the things I was showing you before. The fact that here we have movement yeah, actually we have less jiggering on the and strange movement, but you can see that the horizon is not actually right because we are still attached to the head bone. So to fix that, we will need to change the attachment of the spring arm. Our spring arm is attached to the head bone, and we want it like this one, the one for this camera, to be attached to the pawn itself, to the capsule component. And also there is something we can do with this is camera in transition. You see, if I'm pressing the animation while it's not completed, I'm replaying it. I don't want this behavior. I want to not be able to change, to switch and to input, to actually take in account of the input control for the camera switch when the animation is playing. So the first thing to do for that is to check if we are playing the animation, the transition. It's very simple, we just have to say if we are not playing the animation, we can play it. And so we have to say here that we are playing the animation when we start to play it. You see, you can take a variable and slide it onto a connector to directly have a set instead of grabbing your variable and choosing set, or alt dragging it and then connecting. Here it's already connected, it's very useful. So is camera in transition? Yes. And when we have finished the animation here, we can say it's not in transition anymore. You can call the function again. See, it's working. Okay, let's make some comments. Parameter for third-person view. Yeah, to make a comment box, you just have to press C on the blueprint, and when you have a selection, the comment box will wrap around this selection. It was supposed to be a quick video, but yeah, the bonus round is quite long. Anyway, and here we are going to call this one string arm parameters. Okay. Let's change the attachment. So I struggle a bit doing this, preparing this video, to find the right way to have a very smooth transition. You don't only have to change the attachment, you also have to change the position of the camera arm. If you remember well, here we are attached to the head and at this position, and the third-person view is attached on the center of the capsule. So it's not the same position, you just cannot only change the attachment, and if you do, you have an option actually to spring arm, attach actor, attach component to component, and the component will be either the capsule when we are going on third-person view, or the character, and we are going to attach to the head. So yeah, you have option here: keep relative, keep word, or snap to target. If we snap to target, we won't have a smooth transition. So the idea is to keep word, so you don't change the position at all of the spring arm. So we can attach this, set this here. And this one here. Alright. What I was saying, yeah, in order to have a smooth transition, we have to manually adjust the position of the arm during the animation transition. And for that, we have to, let's see. And also, for that to happen, we have to remove the control, not the control, the attachment influence that we have before changing the attachment. Meaning, we have to detach the component. If we don't, we won't be able to manually adjust its position without interferences from the controller and from the, no, not from the controller, but from the root attachment. Either it's the mesh or the capsule component. So detach component, alright, keep word, we don't want to change the position, and then we play. And we do the same here. We can copy this in case we need to. Okay. So if we play here, yeah, you can see that when we are playing the transition animation, we keep word location, so if we are moving while playing the transition, the camera will go in bad location. So during the updates here, we will set the camera, the arm position and the camera orientation in order to be exactly the same as when it will be attached. Oh, I forgot something. I told you the solution before showing you how to find the solution. Well, yeah, I told you the reason why we have and let's go back. When we have the transition, we have a little offset at the end, yeah. And I told you directly what was bad. I scheduled something to explain you how to find why it's happening, actually. But I spoiled the answer. And so we are noticing that the snap, the little offset happening is happening only at the end of the transition. So we know it's happening somewhere when we finished, okay? And if you want to use a method to find, to track issues, bugs, you can use the empiric method, which consists on testing every element. So if we don't change all these variables, what is happening? Let's see. Yeah, it's perfectly fine. You see? So the issue is caused by one of these things. Let's try only with these two and these two. No snap. So it's coming from here. And as I told you, and as I spoiled you, it's coming from the fact that the camera use pawn control rotation in this case, and not the arm, and in this case it's the opposite. So it's adjusting to the controller rotation at the end of the animation. Yeah, I made a plan and I don't follow it. But anyway, use the empiric our empirical method to track down your bugs. It's working fine. So we were at we can use a sequence here. We were at the point to find or to make the smooth transition manually for the camera. So here it's a sequence. It's just for ordering my code. So first, at each update, first it will play these things, then this thing, and you can add other one. We can remove them. We are going to need only two things, one for adjusting the spring arm parameters, and the other one for adjusting the camera position. In order to see exactly what is happening, I will unplug this one. We won't change the arm length, and we will go here and set it by default to 300. So we will stay in third-person view, but we will change the at the moment we are only changing the attachment. Up, up. So now let's create the camera transition code. I will explain you, but I will not recreate all the steps that lead to find the right solution method, mathematical function to find how to place correctly the camera arm. We take the camera arm and we will set the world location and rotation at each update of the animation. It was a bit German-like, of the animation. And once again we will lerp from one vector to another vector, from one location vector to another vector, and here from one rotation vector to another one. We will once again use the alpha from here. So this value going from 0 to 1 depending on the time value. Here we will use the shortest path to have the shortest rotation interpolation. So linear interpolation for the A will be from the start point. Yes, so we need the mesh. We need to get the bone location for the head bone. Get bone transform. We want the head bone. We want in world space. And with this location, you remember that our first person spring arm is set at 710. So we will use the location and apply it a little offset, and for that we will transform a vector. Transform location, okay. Yeah, transform a location. The location will be so 7 and 10. This is the first person view parameter we have here. And we want, actually what is doing this node is applying a location relative to another one, to a transform one. So transform is basically a combination of the three main three main transform variables: the location, the rotation, and the scale. If you split this, you can see the various vectors composing this transform. So here we have the first person view, A, position, first person view position, and we want the third person view position. The third person view position is the capsule component, okay? And we want the world location. Alright, for the rotation, we want also the starting from the bone position and applying a transform rotation, because if you remember correctly, our first person spring arm, or the switchable one, have a rotation that is not 0, 0, 0. Because the bone is not oriented the same way as the character or the capsule. So this is first person, and for the third person view, I think, yes, we just want get control rotation. Because in first person view, we are attached to the bone, and we have, if you remember, we are not using the bone control rotation. But when we reach the end of the transition, we will switch to the third person view, and in the third person view, the spring arm is bind to the controller rotation. So we want to go to this position, to the controller position, and this is what we are doing here. In addition to this, we also need to move the camera, because it's the opposite for the camera. The camera in first person view is bind to the controller rotation, but in third person view, it's bind to, it's at 0, 0, 0 rotation, but attached to the spring arm, so it's moving with the spring arm. And the spring arm is controlling the rotation. So we want our camera. We want to set the rotation. We want to set the relative rotation, because the camera is always attached to the spring arm. And once again, we want to lerp, so to make a smooth transition, a linear transition. Alright. So the first position is the controller rotation when we are in first person view, and the third person rotation is 0, 0, 0, if I'm correct. Yes, I am correct. So let's see if it's working. Okay, and not totally okay, as you can see. What is happening here? What is happening? So when we are in first person view, the camera is bind to the controller rotation. So when we move the mouse, the camera is moving as well as the character. And when we are switching, it's still attached to the rotation until we reach the end of the animation, of the transition animation. But when we are going back, yeah, you see that we don't have control. And the solution to solve this is just to make this transition, this and the parameters here to change them before the transition animation. So we want to change them here. All right. And if I'm right, this is yes. We are seeing a little. We are not seeing offset. We are seeing a little offset from. No, we are not seeing a little offset. Look, it's working perfectly. Yeah, we can see an offset because the character suddenly adjusts to the camera rotation. And what is nice is okay. And we are seeing this little issue, but we won't see it when we're gonna set back the arm length and to actually really go from first person view to third person view. Here we are still in third person view in both cases. That's why we have this little snap. But now, if we set back things as they were, okay, you see? Perfectly smooth transition, no offset. Nice. And even if we are going, okay, if we are going in this direction, of course you will have, the camera will have to adapt and to find a solution. And actually the camera is doing a little movement, circular movement, but the transition is smooth nonetheless. It's just that, yes, you see, we have the character turning suddenly because now the character is bound to the first-person control system. For that, I don't have really solution, but it's not very noticeable. It's only when you are going forward the camera, or actually going backward with the character and facing the camera, that you have this kind of issues. But in most cases when you are like that, you can even jump and do the transition. It's working totally fine. So it's clearly smooth. In addition to that, we can have a little bonus. As I showed you, you can offset the camera position. And if you go here, what was offset, target offset? Socket offset. Set socket offset. We can create a lerp. So 0, 0, 0 in first person view and 50, 50 in third person view. Yeah, nice. Okay, one last thing I wanted to show you, because we are done here. Adjusting camera location. Arm and camera location, rotation. Anyway, it's nice to comment your code. Even if you're working alone, if you don't work for a while on your code, you will, and you come back some months later, you will be a bit lost, even if it's you that write the code at the first place. And in addition, if you're working in team, it's clearly better to have something well organized and commented in order to have your teammates to understand what you are doing without having to come back to you and to ask for explanation. Alright. Yes, so the last thing I wanted to show you is you can use other LERP method than the LERP, traditional LERP one, for this and for this, but especially for this it will be more noticeable. You can use the is. The is interpretation by default is doing exactly the same as the LERP interpretation, meaning a linear interpretation, but you have several options. And let's try this just a little. So for example, we can use an is out. You see that instead of going linearly to 0 to 1, it's actually you could also make it here directly in the spring, in the animation timeline by changing the property here. You can set to user, and you can change. Come on. Okay. And you can change the curve tangents to have a smoother transition at the beginning, going fast, and going smooth at the end. But I prefer to use it to change this, to have here just a constant alpha, and to change it with this functionality that are doing more or less the same. The one I showed you, it was is in, is out. And here, if we are using only is out, you can see when we are interpolating, so you don't see too much the clipping inside the mesh. And for this one, I was, as I thought, I set exposant. I don't know the name in English. Exponential. Yeah, and you see, you have nice. You can adjust the movement for the transition very easily by just changing this parameter instead of changing the point in the curve. So let's set this like that. Let's remove this one. And we are done. I think so. Once again, I didn't check my notes. So it was easy. It was a bit longer than I expected, like every time, even if I was more comfortable. And I hope you will you learn some interesting things with this video, and that you will be able to make nice functionality for your own game. Or yeah, actually yes. I want to thank you for your support and for your time watching this video, and see you next video very soon. Bye bye.